The topic of this section is channel allocation. When a channel is shared by different users, how this user accesses the channel should be controlled under certain policy. There are two methods of allocating channels: static allocation and dynamic allocation. For static allocation, the channel is like a circuit. Only one person is allowed to use it. As bandwidth is fixed for each user, if a user is idle, the bandwidth allocated to that user simply gets lost or wasted. For dynamic allocation, the channel is open, with some computers be able to access unused bandwidth from others. There is no dedicated bandwidth to users or computers. FDM and TDM are the two basic static allocations. FDM, frequency division multiplexing. It divides bandwidth into fixed number of subchannels. TDM, time division multiplexing. It divides time into slots. Each user can use the entire bandwidth during its own time slot. The main issue of static channel allocation is about the efficiency. We take FDM as the example. It can be very efficient under certain circumstances, in which there is only a small and fixed number of users, and each of them has a heavy load of traffic. However, efficiency is still a problem for static channel allocation. If fewer than n users are currently interested in communication, some portions of spectrum will be wasted. If more than n users want to communicate, some of them will be denied permission. Even the number of users is n and a constant. When some users are quiescent, no one else can use their bandwidth, so it's simply wasted. For bursty data traffic, peak traffic to main traffic ratio of 1,000 to 1, the allocated small subchannel will be idle most of the time, but unable to handle the peak traffic. Dynamic channel allocation can provide better efficiency. Before we get to dynamic allocation, we have to consider 5 key assumptions. They are station module, single channel assumption, collision assumption, continuous or slotted assumption, carrier and no carrier sense assumption. Station module. The module consists of n independent stations, also called terminals. These stations are independent, which means each station can generate frames for transmission. Once a frame has been generated, the station is blocked and does nothing until the frame has been successfully transmitted. Therefore, in this module, it consists of stations which can independently transmit frames. Collision assumption. If two frames are transmitted at the same time, they will collide. In a collision, both frames involved are completely lost. It means as long as there are more than one station sending frames, their frames are all damaged. All stations are capable of detecting collisions. If station detects that its frame is collided, the collided frame must be retransmitted again later. There are no errors other than collisions, which means we ignore other errors caused by channel noise, power failure, and so on. Continuous or slotted time. Continuous time is treated as a continuum, not divided into discrete intervals. stations can transmit frames at any instant of time as they want. Slotted time, it is the opposite way to treat time. Time is divided into discrete intervals, or called as slots. Frame transmissions can only occur at the very start of a slot. This scheme indicates that a time slot may contain 0, 1, or more frames. If it contains no frame, the slot is idle. If one and only one frame, it is a successful transmission, as we ignore all the other errors except for collision. If there are 2 or even more than 2 frames in a single time slot, there is a collision and all the frames get damaged. They will be retransmitted later. Carrier sense or no carrier sense. Carrier sense. Station senses the channel to be used and can tell if the channel is in use before sending frame. If the channel is sensed as busy, no station will attempt to use it until it goes idle. No carrier sense. Stations do not send the channel before trying to use it. Only after the frame has been sent, a station can listen on the channel to determine whether the transmission was successful. If collision, it will send the frame again. Lens generally takes the scheme of carrier sense. And please note that the word carrier here actually refers to an electrical signal on the cable rather than network infrastructures. That's it for this section. Thank you.